Okay, this question is about a toxic chloroalkane that has a boiling point of 40 degrees, and a student carried out an experiment to determine the MR of X by injecting a sample of X from a hypodermic syringe into a gas syringe in an oven at 97 degrees and 100 kilopascals. The student's results are set out in the table 1 and table 2 below. So we've got the mass of the hypodermic syringe filled with X before injection. We've got the mass of hypodermic syringe with leftover X after injection. Now the question wants us to complete table 1 and table 2 by calculating the mass and volume of X. Do not overthink this. It is a simple subtraction. If we've got the mass of the hypodermic syringe filled with X before the injection, and then we've got it after the injection, then assume that everything that has been injected is X, and so you work out the difference. We should get 0.27 grams. We've then got a volume reading on the gas syringe before the injection of X in centimetres cubed, and the volume of X in the gas syringe after the injection of X. So again, a simple subtraction, so 105 minus nothing. So our our volume of X is 105.0 centimetres cubed. Now, the next question then is asking us to have a look at what the chloroalkane must be. Now we've got here 4 options. I'll just move you a little closer. So X is known to be one of the following chloroalkanes: CCl4, CHCl3, CH2Cl2, or CH3Cl. We have to justify this statement by calculating a value for the MR of X and use our answer to suggest the most likely identity of X from the list. We have to give our MR of X to an appropriate precision, and we've also been given the value for R. Now, if I just go back to the previous page. Now, we've been told the temperature is 97 degrees C, and we've been told that we have a pressure of 100 kilopascals. So initially, my thoughts are that I'm going to need to use the equation PV equals nRT. So I'm going to write that down first. Now, what it is I want to work out is the molecular mass of X. And the way to do that is by calculating the number of moles. So I'm kind of thinking backwards. My final point is MR, and I want to work out the MR, so I'm going to need to do that using the equation mass equals number of moles times the molecular mass. So I'm going to need the number of moles. I'm also going to need the mass, but we'll get to that because we've been given it in the question. So I'm going to use the equation PV equals nRT, and I'm going to rearrange that for N. So using my question then, I'm going to identify the values for PV, R and T and ensure that they are in the correct units. So if I start off with P, in the question I'm told that the pressure is 100 kilopascals. Now I need to convert that to pascals, so I'm going to times it by 1,000. So I should end up with 100,000 pascals. I've then been told in the question that the volume is 105 centimetres cubed. That was the one I worked out in the question before. So if you didn't get that right in the question before, but you have used your own volume, you can get carried error marks for this. So I've got 105 centimetres cubed. To convert that into metres cubed, I have to multiply by 10 to the minus 6. So I'm just going to write that as 105 times 10 to the minus 6 metres cubed. I've then been given in the question a temperature of 97 degrees. Now I'm going to need that in Kelvin, so I'm going to add 273 to it. It should give me 370 Kelvin. I'm not going to rewrite R because I've been given it in the question. So I've got my equation and I've got my values. So I'm now going to just enter those values into my equation. I'm just going to substitute those in. So it's going to be P has a value of 100,000 plus V, which is 105 times 10 to the minus 6, over R, which is 8.31, plus 370. So if I enter all of that into my calculator, I get a value of 0.003415 moles. Now, for the purpose of showing my working, I am writing an answer down, but I'm keeping that value on my calculator. Okay, I'm trying to reduce the rounding errors here. So I've got a number of moles and I want to work out the molecular mass. Molecular mass is equal to the mass divided by the number of moles. We've already calculated in the question that the mass of X was 0.27 grams. I'm going to divide that by my number of moles, which again, as I said, I've kept on my calculator. All right, so 0.27 divided by the number on my calculator gives me a value of 79.1 when rounded to an appropriate number of significant figures. Okay, because all my numbers in the question have been given to me as 3 significant figures. So 79.1. The next step is going to be identifying out of these 4 which one of them has a molecular mass or a molecular mass close to 79.1. So for the next part of the question, I'm going to just work through the molecular masses of each of these different molecules. So I've got CCl4, which has a molecular mass of 154. I'm just going to make note of those above the molecule. I've got CHCl3, which is 119.5. CH2Cl2 is 85. And CH3Cl is 50.5. So in this case, I can see that no single one of them has an exact molecular mass of 79.1. However, the closest one here is CH2Cl2. So that's what I'm going to put as the identity of X. Now, the next bit of the question then wants us to suggest the reason, other than the fact that we've been inaccurate with our equipment, why the MR value is different. We also need to explain that. So why is that? Now, the first thing I'm going to do here then is just compare the two values. Now, my calculated value, my experimental value, is lower than the actual value. So because it's lower, I must think about my equations here, okay? So the MR we calculated by doing the mass divided by number of moles. Now if the MR is lower, number of moles must be bigger. Okay, my calculated number of moles must be bigger. Now I calculated M by doing PV over RT. So if N is bigger, then either these two values are bigger than anticipated, or these two values are smaller than anticipated. Well, it's not going to be R, because R is a constant, so it can't be that. The temperature could be smaller than we are anticipating, or the pressure or the volume could be bigger. Now I've gone for the idea that the volume is bigger, so I'm going to suggest that actually some air has leaked into the syringe. So as I've injected X, air has leaked into the syringe, making V bigger. Now do check the mark scheme for this one, because there are quite a few different options that you can have for this answer. The next question then, we've got to suggest with a reason an appropriate safety precaution that the student should take when using the toxic chloroalkane X in the experiment. Emphasis here on the fact that X is toxic. Okay, now because it's toxic, I'm not going to want to breathe it in. Okay, so I want to do something that is going to prevent me from doing that. Now, the easiest way to do that in the lab is to carry out this experiment within a fume cupboard, as it means it will prevent us from inhaling the toxic fumes.